Good afternoon, everyone. So to get started here, let's do a quick warm-up question that is briefly touching on some of the stuff we talked about on Monday. So in this particular question, what we have is that if an object is initially moving with a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? So if an object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? Is it A, 2 meters per second, B, -24 meters per second, C, 16 meters per second, or D, -8 meters per second? So if an object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? So we have 4 choices for you today. Pick one of the 4 that you feel like best answers the question here. Is it 2 meters per second? Is it -24 meters per second? Is it 16 meters per second? Or is it -8 meters per second? Let's take a couple of minutes to figure this out. So we're currently at about 10 out of 14. Let's get another 4 more people, the last 4 people, to respond to the warm-up question. Take another couple of minutes or so. So if an object is moving at a velocity of -4 meters per second, and it accelerates at a rate of 2 meters per second every second, what would its velocity be at 10 seconds? Is it A, 2 meters per second, B, -24 meters per second, C, 16 meters per second, or D, -8 meters per second? We are currently sitting at about 12 out of 14 people, 12 out of 15. So we need about 3 more people to respond to the question. Let's try to get 100%. Let's take 1 more minute to go through this problem here. All right. Looks like we're missing a couple of responses, but I'll start going through this regardless. So first off, what does it mean to initially be going at a velocity of -4 meters per second? Well, this tells us that we are going with a speed of 4 meters per second, but we are going in the negative direction. So what this looks like is that we are indeed going in the backwards direction with a speed of 4 meters per second. Now, the second part of this question tells us that we are accelerating at a rate of 2 meters per second every second. So what does this mean? Accelerating at a rate of 2 meters per second every second. What this tells us is that every 1 second, our velocity goes up by 2 meters per second. Now the key thing here is that this is a positive 2 meters per second, which means that our velocity is going to be increasing by 2 meters per second. So if our velocity, at time 0, if our velocity was initially -4, after 1 second, our velocity would be at -2. At 2 seconds, our velocity would be at 0. So we're just adding 2 every single time. So after 10 seconds, we want to figure out what is our velocity. Well, after 10 seconds, our velocity should increase by a total of 10 seconds times 2 meters per second every second. So that means our velocity should change by a total of 20 meters per second. Now this is telling us that our velocity changes by a total of 20 meters per second. So if we initially started off with -4 and our velocity changes by +20, that means that our final velocity should be 16 meters per second. So our correct answer here should be C instead. So yeah, the key here, I think, is the most challenging part of this, as I think reading the wording of the question and trying to figure out what it means. So when it means that it's accelerating at a rate of 2 meters per second every second, what that means is every second, the velocity is changing by +2 meters per second. So what would its velocity be at 10 seconds? What we're going to do is we're just going to take our velocity, our initial velocity, and then add the change to get our final velocity. So does anyone have any questions about this particular problem? Okay, so here's what we're going to do today. We are going to continue with the lesson we started on Monday. So you should pull up your graphic organizer that we started on Monday. I unfortunately don't have a link to the ones that you have, so you should go to your Google Drive and figure out what your graphic organizers are. If you want a reminder of what they should look like, this is the original document. If you want to see what it should look like. So open this up. I'll give you a minute to do that, and then we will pick up where we left off. So last time, I believe we got to box, I want to say box F. So we are going to try to do the rest of them today. So we'll see. Hopefully I can get through the rest of them today.
Old one. So I thought it was the old one. Graphic coordinator. I didn't know. Hello?
Yep. Okay.
I said I didn't know this was the old one. This was a new one. I thought this was the old one.
This is the one that we worked on Monday. So just whatever the one you worked on Monday, you can continue. This is
I didn't even work on it yet. I thought I finished it. That was the wrong one.
It's okay. It's okay. So we're starting with F. We're starting with G today, so that's okay. Don't worry about the other part. We'll just continue with G. So let's start with talking about what it means to have how we might actually calculate the acceleration of an object. So What we did on Monday is we looked at a bunch of graphs that were telling us that the car was undergoing some sort of acceleration. So they were telling us that the car was, getting faster, or its velocity was getting more positive, or its velocity was getting more negative. And so we sort of looked at acceleration indirectly. Now, if we want to calculate acceleration directly, if we want to actually be able to calculate how quickly a car is accelerating, what we need is we need a way to figure out how much the car's velocity is changing every second, which is just another way of saying slope. So basically, if we want to calculate the acceleration of an object, we need to figure out how much of the velocity is changing every second. So if we're looking at a velocity versus time graph, we're going to be looking for the slope of the graph. Now, the slope of a velocity versus time graph, not a position versus time graph. That's going to be one point of confusion here. So we're going to be spending quite a bit of time working on being able to read graphs and figure out what the graphs are telling us, what kind of graphs they are, and seeing if we can figure out some different quantities from that. Now, one example of acceleration that you might encounter is something like this. For example, the Model S's velocity. So on Monday, we first started talking about how quickly a Model S could accelerate. So in that particular example here, if you remember going to graph, what was it, graph C, I think, and you looked at the questions, right? So if I believe you looked at box C and you looked at question 4, how much of the Model S's velocity change every second? I believe we figured out that the velocity was changing by positive 13 meters per second every second. So every second, the Model S's velocity was increasing by positive 13 meters per second. So after 2 seconds, the Model S's velocity would increase by a total of 26. After 3 seconds, it would increase by a total of 39. So what we might say is we might actually call this, what we might actually say is that the Model S had an acceleration of 13 meters per second squared, which means that every second, the Model S's velocity would increase by 13 meters per second. So if my Model S started with a 0, and then after 1 second, it was going 13 meters per second. And after 2 seconds, it was going 26 meters per second, right? Every second, it's getting faster by 13 meters per second. And so what we do is we call this acceleration. And what we say is that the Model S had an acceleration of 13 meters per second squared, which means that every second, the Model S's velocity would increase by 13 meters per second. So the units for acceleration, we call this meters per second squared. So m is divided by s squared, m over s squared. We pronounce this meters per second squared. So for boxes G and H, I want you to write down what do you think it means? How would you explain what it means if a Model S has an acceleration of 13 meters per second squared? And then I also want you to write down the units for acceleration. And I also want you to write down what the units mean, right? If you just write m over s squared, you might not have no idea. You might have no idea what that means. So I think it also helps to write out the pronunciation, right, which is meters per second squared. So the m is for meters, and then it's over second squared. So give me a minute just to write down what you think it means if a Model S has an acceleration of 13 meters per second squared. And then what the units for acceleration might be. So what we're going to do next here is using the knowledge we had on Monday and a little bit of a stronger understanding of what it means to have the units of acceleration. What I want you to do is I want you to try to fill out this table here. So what I have is a table of times and then I want you to write in the velocities at that particular time. So if I have times 0, 1, 2, 3, 4, 10, and t. So what I want you to do is I want you to write down what is my velocity when after 0 seconds, what is my velocity after 1 second, what is my velocity after, for example, 4 seconds, and then I want you to be able to figure out what is my velocity at after t seconds. So I'm gonna have to try to figure out a pattern here and see if you can write out a velocity for any general time, for any variable t, right? So to do this, I'm going to put you into your breakout groups, and I want you to work with them to see if you can fill out this table here and see if you can figure out, what these velocities are and what the general velocity is at any time that we might call t. All right, so let's take a look at the table here and let's try to figure this one out. So after 1 second, at 0 seconds, our velocity should be 20, right? Because our velocity was 20. After 1 second, our velocity decreases by 4, so it should go down to 16. 2 seconds, it should be 12. 3 seconds, it should be 8. 4 seconds, it should be 4, right? So this is pretty easy stuff. You know, every second it goes down by 4. So how would you figure out what it is after 10 seconds? So you could keep just counting down every single time and then count down another 5 or 6 more times. Or if we're a little bit more clever, which we're trying to do, we're trying to be a little bit more clever, we can sort of look for a pattern. So what's the pattern here? The pattern is here we go down by -4. Here we go down by -4. Here we go down by -4. So every 1 second, our velocity goes down by -4, right? So for example, after 2 seconds, our velocity went down by -8, or changed by -8. After 3 seconds, it changed by -12. So how much would it change by if our time was 10 seconds? Well, after 10 seconds, if each second it's changing by -4, what we get is after 10 seconds, it should change by -40. So now that we know how much it changes in 10 seconds, what we're going to do is we're going to take our initial velocity and then we're going to combine it with how much our velocity changed in 10 seconds. So in 10 seconds, our velocity changed by -40. So our initial velocity plus our change, which is -40, and this gives us a final velocity of -20. So after 10 seconds, our velocity is indeed -20. Now this seems like it's a lot of work because we got to plug it each time, and it's like kind of like annoying. Let's see if we can try to find write an equation that allows us to figure out our velocity at any particular time t. So let's look for a pattern here. So first off, right, all of these is what we're doing is we're taking our change, here, and we're combining it with our initial velocity, right? So we're basically looking at how fast we're initially going, and then we're going to look at our change. So if we wanted to write an equation for our velocity, right, what we're going to want to do is we're going to take our initial velocity, which is 20, and then we're going to want to combine it with how much our velocity changes. And we know that for every second, our velocity changes by -4. So what it means is after t number of seconds, our velocity should change by -4t, right? So after 2 seconds, our velocity changed by -8. After 10 seconds, our velocity changed by -40. So after t seconds, it changes by -4. So now here what we have is we have an equation that allows us to figure out our velocity at any particular time for this problem. So this equation here is what we're looking for. We're looking for a general way of calculating our velocities and accelerations without having to plug it in every single time. Now, if you have any more questions about the jump here to go into equations, you should please let me know and I can try to walk you through it. But we do have a lot of cover here, so I'm gonna try to move everyone along. So the idea is we want to be able to write equations that do our work for us rather than just plugging in every single time. Okay, so now that we sort of have a little bit of a grasp in terms of how to work with acceleration numbers here, what I want you to do here is I want you to quickly write what I want you to do is I want you to quickly find out the acceleration of this graph. So this graph is a velocity versus time graph here. And what we want to do is we want to figure out the acceleration. So I'm going to put you in your groups again, and then we're going to take a few minutes to see if we can try to figure out what the acceleration of this graph might be. Remember, this is a velocity versus time graph. So we want to use that knowledge to try to figure out yeah. Okay, so now that we've figured out so now what we're gonna do is we're gonna take a look at this graph here, and we're gonna wanna try to figure out what is acceleration. So that seems like a big word and a big task, figuring out an acceleration. I feel like it's gonna be pretty easy to sort of look at this and have no idea what this means. So let's quickly review what it means to have an acceleration. So when we have an acceleration, what that means is that it means that something is changing, right? If you're accelerating in your car, it means that your change is speeding. And so when you have some sort of acceleration, it means that your velocity is changing. You have some sort of velocity changing. And what we want to do is we want to figure out the rate of change in our velocity. We want to figure out how much is our velocity changing every second. So we're looking for a rate of change, right? How much is our velocity changing every second? And that tells us our acceleration. Now, another way of saying rate of change is really just saying the slope of something. So if we can figure out the slope of a velocity versus time graph, we'll actually figure out the rate of change of it. So let's take a look at this rate of this velocity versus time graph, and let's take a look at the slope. So to find the slope of something, we're going to look at the rise over run. We basically want to figure out how much does our velocity change over how much our time changes. So in 2 seconds, our velocity goes up by 1. So our rise over run would be our velocity goes up 1 meter per second in 2 seconds. So our slope would just be 1/2. That means that our acceleration, which was our slope, is just 1/2 meters per second squared. And that's it. Nothing more to it. So it seems like a big word, big task. It's very hard to understand what it means. But notice how we've already done this before. We already know how to find the slope of a graph. Now we're just adding a terminology to it, a term to it. So when we're trying to figure out the acceleration of a graph, what we want to do is we want to figure out what is the rate of change of the velocity. How much is the velocity changing every second? And so to do that, what we need to do is we need to look at the slope of a graph. Right? We need to look at the slope of the velocity versus time graph. So that's all we did here is we just took a look at the slope of the graph, and we figured out the acceleration of the graph. So yeah, we've done this before, and I know you've done it in other classes. Now we're just adding a word to it, a little bit of a word to it. Okay. Okay, now this is going to be this is going to be a tall task here. What I want you to do is I want you to write an equation that fits this graph. So you know how like when you plot a line graph, you're trying to find the equation of a line. So this is the exact same thing. What I want you to do is I want you to write an equation for this line, for this particular graph, right? So the point of this equation is I want to be able to know what my velocity is at any given time. So you're basically you're given a line here and you want to figure out the equation for it. And I know in a lot of classes, you probably have the opposite where you're given an equation and you plot a line. This time it's going to be the opposite. You have a line and I want you to find an equation for it. So the reason why we want an equation is I want to be able to figure out what my velocity is at any given time, just like we did earlier in that table, right? When we had the table, we were able to figure out our velocity at any given time. We want to do the exact same thing here. We want to be able to figure out what my velocity is at any given time. So if you want to remember the general format for equations for line graphs is y is equal to mx plus b, where m is your slope and b is your y-intercept. However, this time, so what I want you to do here, so here's how I want you to do this. I first want you to write an equation for this graph in the format of y is equal to mx plus b. So take a look at this graph and then try to write an equation for it in terms of y is equal to mx plus b. Then what I want you to do is if you are able to do that, I want you to try to do the next step, which is try to replace some of these variables with the variables that we will be using for our class. So instead of using y, m, x, and b, we're going to be using our vf, which is our final velocity, vi, which is our initial velocity, t for time, and a for acceleration. So for now, I want you to just ignore that part, and I just want you to write a general equation in the format of y is equal to mx plus b. Then, if you're able to do that, I want you to try to turn that into an equation that uses the following four variables. And then if you can do that as an even more bonus, I want you to try basically write a general equation that replaces y is equal to mx plus b with these four variables. So basically for the last question here, you're basically replacing. So for this question, today what's going to happen is you're first going to write some sort of equation, something like, it might look something like y is equal to 3x plus 1 or something, right? This is your first goal, is to write an equation for this graph in this format. Your next format is to replace some of these variables with these ones. So you might want to replace a y with something, you might want to replace an x with something, I don't know. And then you're also going to have some numbers that are still here, and just keep those. So for the second one, you won't be using all these variables. You'll probably only be using like maybe 2 of them. For the third one, I want you to try to replace all of y is equal to mx plus b with these 4 variables. So basically, you're trying to, each one of these variables corresponds to one here, and I want you to try to figure out a way if you can replace these ones with these ones. So that is the goal right now. At the very least, I think you should definitely be able to do this one, where you can just write an equation for this graph in a regular format. And then I want you to try to replace these 2 variables here with 2 of these. So I'm going to let you get started. I'm going to put you in your groups again, and then we'll see where we are in a few minutes. Okay, so we have, what we're going to do here is now we're going to take a look at see if we can write a general equation for this. So the equation for this particular graph is going to be, the equation for this particular graph is going to be y is, so our general format for graph is y is equal to mx plus b, and our b is our y-intercept, and then our m is our slope. So for this graph, it's going to be y is equal to our slope, which we discussed earlier was 1/2 x, and our y-intercept is here, which is 1. So this is what our equation for this graph might look like. Now what we're going to try to do is we're going to try to replace these two of these variables here, our y and our x, with two of these. So what is our y value measuring? Well, our y value from this graph is actually measuring our velocity. And more specifically, it's measuring our velocity after a certain amount of time. It's measuring our final velocity. So you could say that our final velocity is equal to 1/2 times x. So what is on the x-axis here? It's actually our time. So our final velocity is actually equal to 1/2 times our time plus 1. So now that we've sort of replaced two of these variables, let's try to replace the 1/2 and 1 with more general variables, sort of like this. So first off, what is our y-intercept here? Well, our y-intercept sort of measures our starting y value, right? And in this case, it's measuring our starting velocity. So it makes sense that our equation should be something like y is equal to vf is equal to something times our time plus our starting velocity, which is our initial velocity. And logically, now we just have one thing left, and that is our acceleration here. Now, it's easy to understand, just see why we pick acceleration last, because it's just the last one left. But why do we want acceleration here? So in this case, our acceleration is serving as our m. It's serving as our slope. So it's serving as the rate of change of this graph. And it's basically just saying how much is my y value increasing every second. And so in a velocity versus time graph, the rate of change of this graph, the slope of this graph, is really just our acceleration. So when you have a graph that's y is equal to mx plus b, you're replacing the slope m with our slope, in this case, which is our acceleration, which is a. So this right here, this is going to be our general equation for acceleration, which I will put on the next slide here. Okay, so this right here is the general equation that relates our velocity to time. So this is something that you should try to write down here. You should not try, you should definitely write down here. I believe the groups I talked to, I believe you guys were actually able to figure this out on your own. That was actually very tough. I was sort of hoping that we would be able to get here, but I'm very glad that you guys were. So what I want you to make sure you write this down. This is the general equation that relates velocity to time. And what it tells us is that our velocity, our final velocity at some time t, is our starting velocity, how fast we were initially moving, plus our acceleration time times our time. And this acceleration times our time tells us basically how much did our velocity change during that time. Right. So if I want to know what my final velocity is, I need to know what my initial velocity is plus how much my velocity changed. And how much my velocity change is dependent on my acceleration times my time. So I 100% want you to write down this equation. We will be using it next week. If you don't write it down, you might forget it, and we're going to be using this equation a lot. So make sure you don't forget it. And I also want you to make sure that you know what these variables all mean, because it's going to be very easy to look at this and have no idea what these variables mean. So I want you to try to write down what you think, at least either in terms of what you think they mean, or you can just write down what I wrote down, is whatever is up to you. But I want you to make sure that you have something written down for what these variables mean. Right, so we want to have an equation, and we want to have what these variables mean, which should fill boxes L and M, right? So L is for what do these variables mean, and then M should be our general equation that relates velocity to time, which is this one right here. So once you finish writing this down, I want you to just quickly work on the exit ticket. Unfortunately, I don't think we will have time to work on the practice questions. So I would say try doing it on your own, if you can, before you submit it. But definitely before you leave today, try to work at the exit ticket. So in terms of what is the exit ticket. The exit ticket is a box P on your graphic organizer. It's a quick question. If an object accelerates from rest to 20 meters per second in 5 seconds, I just want you to write in what is the object's acceleration.
What was the equation for k again? I missed it. The acceleration equation for the graph.
Oh, for K. That would be this. Oh, so the one for the above graph should be something like y is equal to 1/2 x plus 1, I think. And then ideally, once you have this equation, you are basically trying to replace the y and your x and your m and your b with these variables right here. So this is the equation for the graph. Y is equal to 1/2 x plus 1. And then what we did is we tried to replace the y and the x and the m and the b with these variables. And when we do that, what we get is an equation that looks like this, which actually looks very similar to our y is equal to mx plus b, right? If we were to actually rewrite this out, this would be y, this would be our b, this would be our m, and then this would be our x. So yeah, once you finish writing down this stuff, try to quickly work through the exit ticket. And then once you do that, you are free to go. I'll see y'all all on Monday.
Thank you, Mr. Hu.
Hey, you.
Thanks,
Hey,
Mr. Hu.
Mr. Who, bye.
Bye.
Hey, thanks, Mr. Who. See you, bro.
See you, Jack.
All right, on Mr. Who.
All right, see you, Jojo.
Thanks, Mr. Hu. Have a good weekend.
Thanks, Mr.
You
Hu.
too. Thank
When
you.
should we
Bye-bye.
submit this?
Sorry?
When should we submit this?
Once you finish, you can just submit it on Canvas.
Without the practice questions, or should we do those outside of class?
You can try doing it outside of class. If you feel like you're really stuck on them, then just submit it without it. But I
Okay.
think you can probably work it out in like a couple of minutes.
Thank you.
Yo, peace out, Mr. Hoop.
All right, peace out, Miguel.
Later, Mr. Who.
See you, George. All right, see you, Russell. Say bye to Raph for me.